Okay, is everybody got this number? Great, fantastic. And you can see, do these numbers make sense? This discrepancy isn't really huge when you take into account this value. 12 to 9.8, taking into account 9.8 isn't huge, and so the discrepancy is small. This discrepancy is a little bit bigger. This is a big discrepancy. It's almost double, more than double, right? So you get a bigger chi-square value. This discrepancy is not that big. This discrepancy is almost double, so you get 2.45. This discrepancy is not that huge, 0.75. This discrepancy, not huge, not huge. And this is actually the tiniest discrepancy, so you get a very small chi value here. So you get a total chi-square. This is your observed chi-square, 8.54. Now the question is, what is your cutoff score? So the fundamental question is, does the fact that you're in community B or A or C make a difference in your vote? And if it didn't make a difference in your vote, you'd expect all of these values to be the same, right? Because I'll show you in a second. But basically, if you find that your chi-square is really big, that there's a huge discrepancy between what your expected and observed value, then these two variables, where you live and your vote, will be dependent on each other. So where you live will determine your vote. And I'll show you how that works. But let's continue and calculate the actual chi-square cutoff. What is the cutoff chi-square? So we need to draw the distribution. It's, always draw it the same way. It's not a big deal. We don't care. But it looks like this. And the cutoff would depend on the degrees of freedom. And this is where it gets a little bit weird. The degrees of freedom is the number of rows minus 1 and the number of columns minus 1. How many columns do you have? 3. And how many rows do you have? 3. So it's number of rows minus 1 multiplied by number of columns minus 1. So it is 3 minus 1, which is 2, multiplied by 2, which gives us degrees of freedom of 4. So degrees of freedom equals 4. OK? Everybody with me? So you just have to memorize that. Degrees of freedom is number of rows and number of columns minus 1. Remember, the degrees of freedom for the one with just one column is number of categories, or number of columns minus 1. That was it without this. But now that you have 2, you multiply them by each other. So degrees of freedom of 4, you go to the table. And what is the cutoff for a chi-square with degrees of freedom of 4 at the 0.05 level? It is 9.488. So your cutoff is 9.488. You just go to the table, go down 4, and then go to 0.05 level, 9.488. Your observed value is 8.54. 8.54. Can you reject the null? No. What is the null? The null says that these two groups are different. So you cannot reject the null. So these actually two groups are not, or the expected is not different from the observed. Therefore, these are independent. So these two variables are independent from each other. It doesn't matter in which community you are. Your vote won't be dependent on the community you live in. Now, everybody with me? Yes. OK, so that's what you have to do for the test. And that's basically all you have to do for this chapter. OK? There isn't much conceptual stuff I will ask you about this chapter.
So when you fail to reject the null, it means they are independent, right?
Yeah. So yeah, they are independent. Let me show you this in a little bit more easier to grasp version.
we did reject the null, would it be dependent always?
If we rejected a null, we would have said that this is dependent on this.
So, but we'd have to specify it, right?
Yeah.
We'd have to say community D, community E.
Oh, so that's a great question. So guys, listen to this. This is a very important question. So Arian is asking whether if we reject a null, can we tell which is really making a difference? No. All we can tell is one variable is dependent on the other, meaning that where you live will result in a different voting pattern than where you live will result in a different voting pattern. If you lived in community A, you might vote more against, and if you lived in community B, you might vote more for. But in this case, you can see it. Sorry, I just erased it. But basically, the discrepancies are not huge. Where you live doesn't really make a difference in what you vote. They're like almost equal. These were equal, and these were equal. So it doesn't matter where you live. If you lived in community A and B or C, you're likely to vote in the same pattern.
And are we going to know, are we supposed to know how to distinguish which population is which?
No. The way you would do that is then you would do a specific chi-square for each one. So you would test this. If you discovered that, in fact, this overall had a significant effect, then you would take this and test it against, or you would take this vote and test it against the three communities and say, oh yeah, most people from community A vote for.
No matter what.
Yeah, yeah. You would ignore one of the levels or one of the variables and just test one variable.
No, we're not going to see that.
No, you're not. You're going to just do an overall chi-square. But let me just make it a little bit simple. I mean, this is a little bit of a complex design we just saw. 3 by 3 gets confusing. So let's come up with a nice way to look at this. I've got it. Males and females, they often differ on things, right? So we would do a contingency table because males and females is a categorical variable. And let's come up with something that, naturally they would differ on that's categorical. Strength is, the problem with strength is like if you measured it, you would measure it, you'd measure it continuous, like, how much fast they would, or how strong their punch would be. Can we think of something a little bit more, like
hair length.
No, that's again continuous. Length is continuous. You want something more categorical, like, no, that's again, like TV shows. Yeah, did you say TV shows? That's a great idea. So TV shows they watch. So the tendency for males and females to watch tearjerker movies versus action. That's a great idea. You deserve the point. You deserve it. You send me an email. So that's a great difference. So let's take a look. Let's come up with some numbers. Let's say you sampled 100, okay, 100 people, and you discovered that maybe let's say overall most people didn't go for tearjerkers. Like most people ended up seeing action movies. Like men determined that hey, they drag their girlfriends to action movies, and what. But and then the tearjerkers, like males, ended up watching tearjerkers maybe 5 and 25, and then action movies would be let's say 60 and 10. Let's exaggerate it just to make it. So let's take a look. So this would be 65 here, right? 65, and this would be 35. So let's calculate the expected, right? Let's calculate expected here. So what's your expected? Your expected would be, so how do you calculate it? It's row over n multiplied by column, right? Row is 30 divided by n is 100 multiplied by column, which is 65. So 30, divided by 100 multiplied by 65 gives you 60. Is that right? Am I calculating it right? Times 65. Yeah, 19.5. And how about this one? 25 divided by 100 multiplied by 65 gives us 16.25. 70 divided by 100. And then 0.7 times 35, 24.5. Oh, screwed up. Okay, so let's take a quick look at this, okay? So you can see when you add these guys together, you get a 30. When you add these guys, you need to double check. You get a 70. And then when you add these guys together, you get a 65. You add these guys, you get a 35. So that now makes sense. Now, look at this. Look at what we've done. When we took this value, we took 30 and divided by 100, we basically were creating a proportion. And it becomes a little bit easier now to see because it's 100. 30 out of 100, 30 divided by 100 is 0.3. So you basically are saying, given the proportion of people who end up watching tear-jerking movies, 0.3, what is the expected value here given this total amount? Okay? So you would multiply 0.3 times 65. Then you will multiply 0.3 again times 35. Okay? And you'd get these two scores. Then when you take this column, this row, you're looking at 70 divided by 100, which is 0.7. 0.7 times 65 gives you this proportion, and 0.7 times 65 gives you this proportion. Do you see how it's basically taking into account the proportion, the proportion here, and you're calculating these expected values based on the results in each column. So these are the expected values. And now if you just look at it, you don't even have to calculate chi-square. You can see how discrepant they are. This is hugely discrepant. This is 15 point. This is approximately 15 points. This is approximately 15. And this is 15 points. And if you square those 15s, you're going to get big numbers, right? Even though you divide them by 19 and 45, still get big numbers, which is a big chi-square. Okay? So even without looking at the expected, you can see that there is a relationship between being male and female and watching tearjerker versus action movies. If most males are actually watching action movies, while most females are actually watching tearjerkers. Very few males are watching tearjerker movies, and quite a few. Very few females are watching action movies.